Hey guys, welcome to this video. We're going to be talking about key features of functions on a graph. Let's get started with domain and range. You probably heard of these before, so this shouldn't be too much of a stretch to go over what that is. Domain are all the x values that can be plugged in, you're allowed to plug in. Whereas the range, those are all the values you get. Okay, so when you plug in your input values, which is your domain values, your output is what your range is. And so your range is dependent on what your domain is. When you have a graph, a lot of graphs have key points like maximums, minimums, and so you can identify different kinds of minimums or maximums. You know, if you look at a graph like this, right? Well, there's a few points that peak and they have low points and high points, and some that are higher than others. For instance, this point right here, that's what we would call a minimum. Okay, it's at the low point between those two values. So that's a minimum. And then so is that point, right? Both of those points are at low points that at when the graph turns back around and it goes in the other direction. Whereas these points up here, we call these maximums. So this is a maximum. And so is that. And some graphs have different maximums that have like higher values or lower values depending on what we're talking about. So for instance, you could have a minimum like this, where there is no lower point than that, okay? The very lowest point is called an absolute minimum, okay? If it has a minimum, but there are lower points than it, this would be considered a relative. Sometimes it's called a relative or local minimum, meaning that there are lower minimums than that, but at that specific part of the graph, it is considered a minimum, but that one's clearly lower, so that would be the absolute. The same thing can apply for maximums. So if I draw a graph that has looks like this would be considered a absolute maximum, whereas this one's simply a relative or local maximum. So this is the very highest maximum, and this is a maximum, but there is a higher spot. And not every graph has an absolute maximum. For instance, you might have a graph that might open down on the left side and up on the right side, and there is no absolute anything, right? This is a maximum here, but there's a higher point because that arrow keeps pointing up. So this would be a relative max. And this right here is a relative min because while it is a low point there, that graph will go down forever. So there are some graphs that don't have absolute maxes or mins. But in general, knowing that a maximum is the peak and the minimum is the valley, the low point here. On a graph, there are such a thing as increasing and decreasing intervals. Okay, so basically, if a graph goes up as it goes to the right, then that graph is considered increasing. Okay, now the intervals, we're talking about x values. So I only want to know between what two x values is that graph increasing. And the same applies for decreasing. Decreasing would go down and right. Finally, we have graphs that might be considered positive or negative, and that has to do with the x-axis. So if you have an axis, let's say, let me throw this out here, xy axis here. If you have a graph that kind of spans maybe part of both sides of it, let me use this color here. Well, then the part that's above the x-axis, So these parts right here, those would be considered positive intervals. And again, I'm just talking about x values. So between this x value and that x value, between those two x values, would be considered positive because that's above the, I said y-axis here, but it's supposed to say x-axis, above the x-axis. Now a negative interval is going to be an interval that's below the x-axis. So if I look over here, these are negative intervals. And again, we're talking about x values. So between these two values here, those are negative. Between these two x values here, that graph is negative. So those are a combination of all your different types of intervals. We'll get into how to write those in some of the examples. You're going to see different notations. So for your notations with intervals, when I say x is less than 5, remember that's less than, then I'm talking about on a number line something that looks like this. I would do an open circle at 5 and everything to the left. Now that's going to go on forever. So we say from negative infinity, because the negative is on the left side of the axis, until you hit to 5, that would be considered an interval notation representing x is less than 5. Similarly, you could say x is greater than or equal to 4. Well, I want to include negative 4 here. So if I do a closed circle, because of that equal sign, we would put negative 4 and everything to the right because it's greater than or equal to. So to the right is infinity. So everything greater than or equal to negative 4, you'd put a bracket, a square bracket to incorporate the negative 4 into it. Whereas you'd use a parenthesis if you do not want to include the number. So less than 5 doesn't include 5, so it would just be a parenthesis, not a bracket. Whereas greater than or equal to 4, that equal is going to make sure that I close that circle at negative 4 and make a square bracket. We can also do between numbers. So if I want to say between, this is between, we would say x is, while it's greater than negative 3, but it's less than or equal to 8. So we'd use a parenthesis at negative 3 and a square bracket at 8. And on a number line, it might look like this. You'd have negative 3 here. You would have 8. We'd close up that 8, but keep that open. And we would shade between those, okay? So all values between those. And while I didn't have an example typed, all real numbers is simply every value. So you would say parentheses negative infinity to infinity. All right, the next 4 examples will deal with how to write those intervals and whatnot. So hopefully this video just was a good overview of kind of understanding what these intervals mean, and we'll get into writing them in the next video. Thank you for watching.